Okay. So if I record, if you're watching this video later on, if you're not in the Tuesday, Thursday, spring 21 semester, don't listen to this part. But we do have a test if you are in this class, which is Tuesday. So this will be the last section, 3.4 before the test. And just like the other two tests, I'll open it up. You'll have that day to do it. Set aside, an hour and 15 minutes. And pretty straightforward. I mean, you guys have already taken two tests with me now, so you kind of see the protocol. Okay. Any questions for from any of the sections before, from 3.1, 2, or 3? They all build on each other. So any questions from those three sections? Before I get into this. Really, there's only two concepts we're going to cover today. The second one is just a big one. Yeah, and if you look at this section, it's not that long. It's really kind of, it uses all the knowledge we've learned in the last really three sections to solve. So the first thing section 3.4 talks about is the rational zero theorem. Rational zero theorem. So let's talk a little bit about what that means. First off, a rational numbers are any number that you can write as an integer over an integer. So, like 1/2, -4, 17, 2/3, those are all rational numbers. Irrational are going to be, square root of 2, pi, things like that. Or also non-rational numbers would be the imaginary. So if we had an I value going on, things of that nature. So this only works to find rational zeros. Okay, so if our polynomial has rational zeros, it's going to come from this theorem. So I'm going to write that down. So if, and it's a big if, our polynomial has rational zeros, this theorem gives us the pool to choose them from. Okay, this theorem will give us all the options if the polynomial has rational zeros. So if the polynomial has rational zeros, it's going to come from this group. If it doesn't have rational zeros, it just doesn't come from this group. Okay, and what we actually use the factors of the constant and the leading coefficient. So let's look at this. Really, the best way to do this is by example. Okay, so if we let me look at one with, it's kind of a little more, yeah. I'm going to look at example 2 here. We've got f of x equals 15x cubed plus 14x squared minus 3x minus 2. So the question will state, list all possible rational zeros. List all possible rational zeros. So the way we do this is, first off, you need to write this in descending order, okay? And we're going to look at the leading coefficient and the constant out there, okay? The leading coefficient and the constant. So first, I'm going to find all the factors of the leading coefficient. Actually, I think it's the constant first. It doesn't really matter, but to put it in order, I'm going to do the constant. So factors of the constant. Well, the constants, now I'll tell you the sign doesn't matter. We're just going to look at the number. You can even think of it as the absolute value of that number. So since it's -2, we're really just going to look at 2. Well, the only two factors of 2 are 2 and 1, right? Those are the only things that are divisible into 2. Then we're going to look at factors of, I'm going to be a little lazy there, Factors of the leading coefficient. Factors of the leading coefficient. Well, our leading coefficient is 15. And I'm going to think down, like what's divisible into 15? Well, 15, of course, is always divisible into 15. You can always start with the actual number. And then, what is it, 5, 3, and 1. 1 will always be a factor, and the number you start with will always be a factor. 15 is also divisible by 5 and 3. So if we want a list of all possible rational zeros, so here's how we actually find this. You actually make fractions out of every single combination here. Now the constant has to be on top, the leading coefficient has to be on bottom, okay? The constant has to be on top, and the leading coefficient has to be on bottom, but every single combination will be our possible rational zeros. So let's start here. I'm going to start with the factor of the 2 of the constant, and I'm going to divide it by each one of these. So 2 over 15, 2 over 5, 2 over 3, and 2 over 1. Now, I know that's just 1, or I know that's just 2. I'm just writing it there for now. So you take this first constant and divide it by each one of these, okay? Then you take this second constant, the 1, and you do the same exact thing. 1/15, 1/5, 1/3, and 1 over 1, right? 1/15, 1/5, 1/3, 1 over 1. Now, once you get done with that, you have to do the plus or minus for each one of these. So really, it's not that all of these are the possible rational zeros. It's that each one of these, positive and negative, are the possible rational zeros. So I'm going to write that down underneath here. So our solution looks like this for list of all possible rational zeros. Plus or minus 2/15, plus or minus 2/5, plus or minus 2/3, plus or minus, that's just 2, plus or minus 1/15, plus or minus 1/5, plus or minus 1/3, and lastly, plus or minus 1. Okay, so there's a lot of options here. Now, this isn't typical. I wanted to do one with a lot of options, but this is not always typical. But this has a lot of different possibilities. Now, we know from the previous 2 sections, there's only 2 zeros, or I'm sorry, not 2, but 3. There's only 3 zeros. The degree is 3, right? But these are all the options if we have a rational zero, okay? If we have a rational zero, it's going to come from that group. See if I can find another one, just to do another example of it. And then really I'll show you in the next, as we go along, we're going to use this every time. So you'll see examples as we go and how it helps us, okay? So let's do one more. I'm going to erase this. Actually, I can write above it. You're still writing this stuff down. So let's say we had g of x equals, I'm going to steal one. This is like a checkpoint question. 4x to the 5th plus 12x to the 4th minus x minus 3. Same question. I want you to list all possible rational zeros. I'm not going to write it twice because it'll just kind of take up too much room. So list all possible rational zeros for this g of x function. Well, remember, we've got to look at the constant and the leading coefficient. So my constant I'm going to write first. So the constant is really positive 3. Its factors are 3 and 1, right? There's no other factors for 3. 4 of those a little different. We could have 4, 2, and 1, right? 4 it goes into 4, 2 goes into 4, and of course 1 goes into 4. And then we just have to make the fractions here. So, okay, I'm going to go off this. So remember, you've got to be careful. Make sure that the constant is written on top when you do this. Okay, the factors of the constant are on top. So I get 3 over 4 plus or minus. I'm going to be a little lazy on this one and just automatically do the plus or minus. And then I've got 3 over 2 And then I've got 3 over 1. Well, that's just 3. Okay. And then I've got 1 over 4. And then I've got 1 over 2. And then I've got 1 over 1. Boom. There we go. There's our kind of pool. Think of it like a pool of rational zeros. Now this one only has 5, right? And there's 1, 2, 3, 4, 5, 6. There's 12 actually up here. So it might have 5. It might have 1. We'll see that here in a little bit. But it's just this pattern, and you'll see each one that we do. I'm gonna kind of make this part A. What are all the possible rational zeros, and then we'll solve for the zeros. Okay, we're gonna get to actually solving for the zeros of the polynomial state. And hold on. I don't know if I didn't mention this before, or if it's in this section. If not, I'm going to just go over it now. I'll just go over it now because I must have skimmed over it. Well, I think this book goes over this. Oh, no, it's kind of a hint. Okay, so when we're solving zeros, I bet it was in a previous section. I didn't mention it. When we're solving zeros, it turns out. Let me write this down. It's important. Any non-real or irrational zeros will occur as a pair of conjugates. So any non-real or irrational zeros will always occur as a pair of conjugates. I'll show you as we're working, you'll see an example of this, and I'll point it out and say, hey, look, there's that complex conjugate. But a conjugate, remember, is just A plus B, A minus B. That's a conjugate, okay? So if we have imaginary solutions or zeros, they're always going to occur as a pair. And the same with irrational zeros. So it's kind of interesting. Like if we look back at that one, and I need to hit rewind now because I made it go away. But if we look back at that previous example we just found about all the rational zeros, the pool, remember that was a 5th degree polynomial, right? Well, it turns out non-real and irrational zeros have to occur as pairs. So that means because this is an odd degree, it has at least one rational zero. That's the only other option. Non-real, irrational, or rational. Those are the only 3 options of numbers we have right now in the universe. Okay, we haven't found any other ones. So therefore, if non-real occur as pairs, and if irrational occur as pairs, they have to be even, an even number, right? Well, our degree for that example had a degree of 5. So that means we have to have at least one real, or at least one rational. So at least one of those in that pool that we wrote is one of the zeros, okay? We're going to go over and, kind of an easy way to find the zero. I mean, I say easy, it's going to be kind of a shortcut way, but it's going to be nice to have that pool available so we can see where they might be from, okay? So let's do this. This is exciting stuff. And I'm going to do a real basic one first. I'm going to try to go real slow because I know no one's asking questions. And this is typically when students ask the most questions because it just seems very complex. Okay. So let's look at how the questions in this section are going to be presented. And I'm going to steal an example straight from the book. This is on the bottom of page 378, if you're following along. And it just says find all the zeros, and it gives us a function. F of x equals x cubed plus 2x squared minus 5x minus 6. Okay. This isn't the best starting example, but that's fine. We'll make it work. So f of x equals x cubed plus 2x, and all it says is find all zeros. Now I need us to remember all the things we know so far. One, the degree is 3, right? This is in descending order, the degree is 3. Okay, so I know that I'm going to have 3 zeros. Now I might have repeating zeros. Remember, repeating ones, if they repeat twice, they bounce off the graph, you know, all that fun stuff. Review from a few seconds ago. But I know I'm going to have 3 zeros. I might have repeating, so it might look like I only have 2 or 1. What else do I know? I know the end behavior and all that fun stuff. I'm not going to go over that. You can go back and look at section 3.2 lecture. But also, I just found out the pool of rational zeros. So I'm going to do that first. Even though it says find all zeros, I'm going to say part A, find all potential rational zeros. Find all potential rational zeros. And this is, again, another example of what we were doing just a minute ago. Okay, so I'm going to look at the constant first. I've got a 6. 6 is divisible by 6, 3, 2, and 1, right? My leading coefficient for this one is nice, okay? It's only 1. 1 is only divisible by 1. So my potential rational zeros here are just plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. Okay. No one's in here. I can take my mask off. I don't know why I'm not sure with the mask. It's a habit, I guess. Okay. I'm going to ask you guys, look, there's no one in here, so I'm just talking to Zoom world right now. For part B, it's going to say find. Now I'm going to say find all zeros. Now, I want you to raise your hand if you want to talk, so you don't feel like you're talking over someone, because I know that's so annoying. And if you want to say something, but then you just don't want to talk over. So if you want to tell me through the speaker, just hit the raise your hand button, or put your hand raised thing in chat. If not, you can tell me in chat. And I'm asking you this. I'm not going to do anything until you give me an answer. One of you 4 or all 4 of you 4. How do you think we can find the zeros? Now, this doesn't factor like the ones before. So it's not going to factor like the ones in 3.1 and 3.3, or not 3.1, but not like the ones at the end of 3.2 and 3.3. How could we find the zeros? I'm going to sit here. I'm going to let you think. And I really want you to use your brain on this one. That beautiful thing that has developed over time into something that just wants to sit down and watch Netflix. How do you think? And I'm going to say, not that there's no wrong answers, there's probably just less efficient answers, but there's no real wrong answers. I mean, other than I just don't do it, I guess. Whew. How do you think we can solve for these? Be here a while. Nobody says anything. Forcing them to say something. What do you think, Alex?
You would input some. Man, I don't know.
I like the word input. We'll go there. Okay. How could I find out if one of those is a zero? How could I do that algebraically? How could I find it? Like if I wanted to know, hey, is the positive 6 here a zero? How could I find out if it's a zero or not?
Inputting it in the equation.
Okay, what will we get back if it's a zero? What would we get back? If I plug 6 in, what would I get back if I know it's a 0?
My brain isn't working.
Okay, I'm going to emphasize a word again. If I plug 6 in, what should I get back if it's a 0?
Would it be 0?
Damn, you're good, Alex. You're good. No, it is. It is. So that's one way to do it. And I'm going to tell you, that's a long way to do it, but that's one way to do it. So I'm going to show you. If you're like, man, I don't know how to, I'm not sure what to do. I could go through each one of these to check to see which one's a 0. So I'm going to kind of quickly do this. I'll use my calculator. I've got one floating around here somewhere. So I'm going to go through. I'm going to start with the 6. We might just get lucky, okay? And it'll be a 0. So I'm going to take f of 6. Now remember, this is that remainder theorem from the last lecture. And the remainder theorem said if we plugged in a value for the function and we got back 0, it meant that value was a 0. If you go back to 3.3, that's what that was talking about. So I'm going to take 6 and I plug it in. 6 cubed plus 2 times 6 squared minus 5 times 6 minus 6. I'm just going to plug that all in to my calculator. So let's see here. 6 cubed plus 2 times 6 squared minus, I'll put in 30. I can do 5 times 6. Minus 6. Accidentally threw my calculator down. That's 252. That is not what we needed to get, right? So I'm going to strike that one down. But you know what? I know that's not a 0. That's progress, right? I know what isn't a 0 now, 6. Okay, let's plug in negative 6. So I'm going to do the same thing, negative 6 cubed plus 2 times negative 6. If you know some quicker way to do this, then do it. That's fine. Okay, so I'm going to say, make sure to use parentheses, math cubed plus 2 times negative 6 squared minus 5 times negative 6 minus 6. That's not one either. I got negative 120 there. Okay. So hey, I know 2 of those aren't rational zeros. So let's check out 3. Okay. So we've got 3 cubed plus 2 times 3 squared minus 5 times 3 minus 6. So let's see here. 3 cubes 27 plus 3 squared is 9 plus 18. Minus 15 minus 6. Nope. I thought that was one of them. I guess I was wrong. Nope. Yeah, I'm wrong. That's 24. Okay, let's check negative 3. Okay. Negative 3 cubed plus 2 times negative 3 squared minus 5 times negative 3 minus 6. Oh, boom. I found it. Guys, look up here. I'm zooming in. I don't know if you can see this. Boom. I plugged in negative 3 and I got back 0, right? So that means negative 3 has to be a 0. It has to be. Okay? And look, for this question, that's all I need. We know how to do, if you did the homework from the last 2 sections, you will know how to finish this question now because you know one of the zeros. Remember the last few sections that the end of the homework said, given a 0, find the remaining zeros, right? Given a solution, find the remaining solutions. We know there's 2 more solutions out there, right? Because it's a degree of 3, so we can finish this up. And I'm about to do that, but I'm going to pause right here for a minute for any questions. So you 4 that are in the class right now, please don't feel like you aren't understanding this. And I promise you're not the only one. This is not the easiest concept, okay?
So it's just inputting numbers?
Yes. Now I'm going to go over a more efficient way to do this, but I need you to know where it's coming from first, Alex, okay? And the efficient way doesn't work well if we have goofy numbers. It just works really well if we have numbers like -3. Okay.
Far out.
So sit with me. I mean, it'll just be a little bit more efficient. I think my marker is going on. Okay. Well, okay. So now this really turns into a 3.3 question. Look, if I know -3 is a 0, and I did the homework from the last section, what would I need to do next? If I know -3 is a 0, what do I need to do to find the other two zeros? What did we do yesterday? What was the, or not yesterday, what was the topic of the last lecture? Yeah, I found a seat. What was the topic of section 3.3? What did we learn to do in section 3.3?
I forgot the actual name of it because in my brain it's special L.
Yeah, okay. What was special L? What did it do though?
It shows it's a way to like find what to input in the please help me. My brain is not working today.
What, I mean, the other three in here, if you want to just put it in chat, what was the entire lecture about in section 3.3 in the last lecture? What did we learn to do in section 3.3? If you want to flip your book over like 4 or 5 pages, it's probably titled at the very top of the page. What did we learn to do in section 3.3? Yeah, it's the title of section 3.3. What did we learn to do? And you're right. Alex is right. I know. I mean, his brain thinks of it called the special L, but I don't really care what you call that. What the process we learned. I need you to know what we were actually doing though, and what it gave us. What was that titled? Do you guys have your book in front of you? If you do, you can just go back to 3.3. What was it titled? I'll give you some brownie points. Or go to YouTube. Well, no, I guess I didn't title it. Probably in there. I got time. I got all kinds of time. Just tell us. God, why are you being like this, Mr. Shirley? It's because I need you to know the words, and I need to know why we're doing this, right? It is just a process, but it's that idea of using logic to build on itself and to learn to really perform a larger operation based on other processes that we've learned in the past. You don't get that in other classes typically. Okay, what was it called? So, do any of you 4 have the book in front of you?
So my book says dividing polynomials,
There it is.
remainder.
Perfect. Stop right there. Dividing polynomials. So once we have a 0, which we do, we know -3 is a 0. We're going to have to divide that 0 out. And really what we're going to do is we're going to divide the polynomial out that's attached to that 0. Okay. Which is what you did at the very end of 3.3. And I'm going to tell you, this is going to look really goofy if you did not do the homework or if you didn't watch the lecture from last time. So let's do that. So if I know -3 is a 0, we're going to do what Alex called the special L. I like that. And this is our original function. We write out the leading coefficients. And then we just divide it out. We do synthetic division. It's called synthetic division, Alex. Bring down the 1, -3, add -1, 3, -2. Add, you get -2. -2, -3, you get +6. Then you get 0. Now, we knew that that was going to be 0 because we already knew that this -3 that we put right there, right? Remember, it was a potential 0. We already knew that this was a 0. So therefore, if you did not get a 0 here for your remainder, so we did something wrong. We did something algebraically wrong, okay? But what did this mean? What it meant was that we factored this bigger polynomial. And that polynomial now looks like this. Remember, if negative 3 is the 0, x plus 3 was the factor. I went over that at the beginning of 3.3 for a reason. And then I'm left with this polynomial. Now, this is the constant. This is the x and the x squared. So it's x squared minus x minus 2. Okay? Guys, this is the easy one. So if you've got questions you need to ask now, or if you're like, man, I think I'm just going to have to watch it 10 times. I understand that too. Okay, now just like in 3.3, look, okay, let's talk a little bit. I'm going to make a goofy reference. And if you don't watch this TV show, you won't get the reference, but that's okay. You'll know what I'm talking about. For this section, our goal is to factor the polynomial until we get a quadratic. This is a quadratic, right? If you watch New Girl, they play a game. So I forget what the game's called, but it has to do with the floor is lava, right? And the couch is the safety place. We've all played this as a kid, maybe as an adult, where the floor is lava and you got to bounce around the living room, and then you got to get to your safety couch. Well, a quadratic in this section is going to be our safety couch, because we know we can solve a quadratic no matter what, okay? We can factor it. We can do the, for this one, we wouldn't be able to do the square root property, but we could also use the quadratic equation, okay? And now that I factored one of these out, it was a degree of 3, right? Since it was a degree of 3, I only needed to factor one factor out to get it down into a second degree. But now that it's in a second degree, I'm going to just solve the quadratic. I'm going to set that equal to 0. And I'm going to get my last two zeros. It's what we've been doing since day one. Day one, probably was an introduction lecture, but day 2, we reviewed how to solve quadratics, okay? Day 1, I went over how to be successful in this class, which is watching lectures, doing the homework. And then day 2, though, we went over quadratics. And this is why it led us to this, actually. So we can solve this one out. This one factors. If you don't see it, just use the quadratic equation. But this one does factor. It's x minus 2, x plus 1, right? Multiplies to give me negative 2, adds to give me the negative 1. That's our last two factors. If we wanted to, we could write these two factors in there now. But we have our last two zeros. 2, right? Because if it was minus 2, it would be a positive 2. And then negative 1. Okay? 2 and negative 1. That's my last two zeros. Now remember, the last one was, or the first one we found was negative 3. So I'm going to write those all out like this. And notice these were two options back in our group of potential rational zeros. We just didn't get to those yet. Okay? So for this example, all 3 of our zeros wound up being nice rational zeros. Okay? They all wound up being nice rational zeros. Okay, now I'm not going to sit here and ask you this question and wait for an answer, but there is a way to see these quite easily. Visually, if you're a visual person, right? There's a way to see that all 3 of these are a 0, and it's really, really, really easy to see on a graph, right? So I'm going to kind of start this question over. And what I tell students to do first, after you find all the potential rational zeros, is I tell them to graph it. And you know, Alex, I told Alex a second ago, I'm going to show you a more efficient way to do this. I'm going to show you how to graph it. Now look, this is kind of a janky way to do this, but if you've never used these calculators before, which I know we have a few people in here that haven't, I'm going to go step by step, and I'm just going to go up to the camera and show you the buttons, okay? So if I wanted to graph this function, okay, check this out. On your calculator, hold on, let me move this around. You can tone me out if you know how to do this already, that's fine. But on your calculator here, at the very top left key, it's a y equals. I'm going to click it, boop, y equals. And it gives me all these options for graphs. I don't know why I think this is hilarious. And I'm going to put in that function there into here. Now, the main thing is for the x, the variable x, you've got to use this x comma t comma theta comma. Now, the lighting here is horrible, but it's that button next to the alpha key. Okay, that's our x button. So if I want to put in x cubed, I'm going to click the x button. Notice it brings up x. Now it's got to be cubed. So remember, I'm going to put in the caret button. That makes it in the exponent. And then I'm going to put in 3 because it's cubed. Boom, I've got x cubed. Now I got to get out of the exponent, right? Because the next variable is 2. So to get out of the exponent, I use the little arrow key here. Boop, that gets me out of the exponent. And then I'm going to put in, was it plus 2x? So I'm going to say the plus button, which is, I think, right above the enter key down here. Plus. And then I'm going to do 2x squared. So 2, I hit the 2 number. Remember, it's x comma theta, that one. Boop, x. Now to square it, it's a little easier because there's actually a square button. Where is it? Yeah, it's by the comma over here. You can just hit that and it brings up x squared. And then we got minus, make sure to use the minus key, minus 5. And then now I just need the x button and then minus 6. Boop, minus 6. And look, I have this function written into my calculator. So I want you to do that real fast, you guys that are in the class. Put that in your your graphing calculator. And then when you get done, I want you to hit the graph button. The graph button is on the very top right. That's the graph button. And let's see how this looks. When I hit graph, I don't know what's going on here on the left. What in the world? Let's see. I'm going to hit zoom standard. Yeah, if you've got goofy stuff on your graph like I just did, if you hit the zoom button and hit standard, so hold on, zoom, hit the zoom button, and then if you go to standard, it'll get you back into like a standard mode. Okay, so boom, there's my graph. And guess, or not guess, but let's logically come to the conclusion of where this line crosses the x-axis, and you won't believe it. It crosses, there's my finger, at -3, boop, -1, and +2. Kind of neat, okay? So look, at the very beginning, when I was like, hey, how do you find all the zeros of this graph? If one of you would have yelled out, oh, just put it in your calculator, you would have been done. Because all 3 of these rational zeros, or all 3 of these zeros are nice integers, right? We would have seen them automatically on a graph. Another way to do this is by looking at the table, okay? And I like doing this, so I'm gonna write it over here. You have to hit second graph, okay? You've got to hit second graph. So if you have that function in there, let's go back to my, oh my gosh, awesome. So I'm going to hit the second button, which is the very kind of top left in the normal keys. And then I'm going to hit the graph key. And you'll notice table is the option above that letter. You just can't read it right on my calculator. And it creates a table. Now look, we know when y equals 0, look at my finger here. When y equals 0 and we get an x value, that's an x-intercept, which is a 0. So if you look at this table, I'm going to really zoom in here. You'll notice we need to find where y equals 0. Well, y equals 0 right there at x equals -3. Hey, that's one of my zeros. And then same thing right here, y equals 0 at -1. Hey, that's also one of my zeros. And then when I go down to +2, I get the same thing. So wherever y equals 0, you also have a 0 of the function, of the polynomial, okay? So if you would have told me at the beginning, hey, just put it in the table in your calculator, you would have been right as well. Okay, I'm not trying to imitate Alex. That's not what Alex sounds like. I'm just saying if any generic student would have said that, they would have, you would have been, and you would have been done. Now, guys, listen, you would have been done because this is an easy function. I shouldn't say easy. This polynomial has nice integer zeros. And so the rest of this lecture, we're going to talk about, well, what if we don't have nice integer zeros? What do we have to do then? Okay. So I'm going to stop right here. And I know I've gone over a lot of tutorials now on the TI-84. Do you guys have any questions? I want to make sure that you're getting this because it leads to a harder topic we're about to go over. Okay. Do you guys have any questions? And please don't be afraid to ask me. If you want to do a private chat on the side and send me a question, you can. I think you hit the, it says to in chat. Instead of everyone, you can put down me. I think it's either Robert Shirley or Mr. Shirley. And you can send me chat and I won't even say who sent me the question. Okay. And you get to secretly ask me questions during the lecture. Okay. If you just don't want to feel, if you don't want to feel dumb, because I promise you're not the only one with a question. Okay. I'm going to wait just a minute. I'm going to find a really good example for this next one. And then if I don't have a question to answer, I'm going to find a really good example and go over it. Okay. Okay, let me erase this. Oh, yeah. Okay, so now I'm going to write my strategy out now that I've gone over kind of the long way. For any of the questions that say find all zeros, first, I'm going, we'll call it A. I'm going to find all potential rational zeros. Just find all the potential rational, remember using the constant over the leading coefficient. Part B, that's really hard to see, isn't it? So I'm going to just tell you, find all potential rational zeros, then I'm going to graph it. And then C, then you just start dividing out zeros. You got to find the zero and then divide out the zero, okay? I know that might be hard. It's really hard to see on mine, but it's because I want to leave some gaps here. So find all the potential rational zeros, B, graph it. Graphing it, or I'm going to say graph or use the table because it'll tell you a lot about the function. And then start dividing out the zeros that we know are zeros. Okay. So let's look at an example now. I'm stealing this from the book. It's f of x equals x cubed plus x squared minus 5x minus 2. Oh, the potential rationals are going to be easy on this one, okay? Because we have a prime number in both spots. So potential rationals are going to be pretty easy. So for part, and I'll write this down. For part A, let's find all potential rational zeros. So remember, I do the constant on top. So that's 2 and 1. That's the only thing, the only factors of the constant. Then I'm going to do the leading coefficient. Well, that's just 1. So our potential rational zeros are just 2 over 1, and 1 over 1. That's it. That's kind of cool. I'm hoping, the squiggly line, hard to do. Squiggle bracket. I'm hoping one of mine is one of these zeros, because again, we have a third degree polynomial. We're going to go over what if we have fourth degree next, but I've got a third degree polynomial. So if I can just divide out if one of these is a zero, if I can divide it out, boom, I've got a quadratic, boom, that's my safety couch. I know how to solve a quadratic, okay? So let's do that. I want you to graph this function. So graph this function. And then tell me which one of these, because I think one of these is a zero. So from the graph, tell me which one of these is the function. Or you can use a table too if you want. You can just put it in chat. It's no big deal. Remember, it's y equals, put the function in, If you don't remember which button to press, if you're watching this later, just rewind it, right? But if you guys are in class and have a question, just ask. It's not a big deal. Rather you get it right. So it's x cubed plus x squared minus 5x minus 2. And when you hit graph, can you see where this line crosses? Does it cross at -2, +2, or +1 or -1? I'm going to go get some water real fast. Okay, I'm assuming you don't have your calculator in front of you, which is why you're not telling me in the chat where the 0 is. You need to get that calculator. There's one that works pretty well. That's a free one. I probably shouldn't. I don't have my app on me or my phone on me. I think it's called like Calc 84. Calc 84, and I think it's in the App Store. It's a little different, but most of the buttons are the same. And yeah, if you have to use it, it'll work. It's just not the best. It's not the best, but it'll work in a pinch. Okay, so what happens when you graph this is you find out, hold on, I'll show you up here. This is what the graph looks like, okay? That's what the graph looks like. And now notice, two of those zeros, two of those x-intercepts don't occur in a nice integer, right? One of them does, but two of them don't. It looks as though the graph crosses at +2. Hopefully you guys see that. I can't really see the screen that well. I'm just shoving that calculator in your face, okay? But the graph looks something like that. And if you want to go back to look and see what my equation looks like, if yours doesn't, that's what my equation looks like, which is what the equation should look like. So if yours looks a little different, you're not going to get the same graph. So it looks as though it crosses at +2. So now, okay, when you know what Alex said earlier about plugging in to find the 0, well, you don't have to do that now. So it takes the guess check out of a lot. For this example, it takes the guess and check out of it, okay? So we're just going to put in +2. Actually, what I'm going to do, I'm not going to put it in. I'm going to divide it out. Because if I divide it out and I get 0 as a remainder, I know it was a 0. And if you hit the table button, okay, that'll work, Alex. Yeah. Yeah, and I'll tell you, for what we're doing today, that app, I believe, has exactly what we need. The graph function's a little goofy on that app. So it won't be like, if you go to graph out of the app, it's just a little goofy. And it won't follow the exact as the calculator. So let's divide out 2 now. Remember, 2 is the 0. So I go back to the original. I've got 1, 1, -5, -2, 1, 2, 3, 6, +1, 2, and 0. Hey, it worked out. And we knew it would work out. That is definitely a 0 based on what we found so far. Okay. So we found one of the zeros, 2. We divided it out to show it was a 0, and we have stuff left over. So now what we actually have is this function factored down. 2 is actually x minus 2. And we wind up with x squared, 1x squared plus 3x plus 1. And if you're lost at this point, you need to go back to 3.3, watch that lecture and do that homework, okay? Because it doesn't take long and this stuff becomes the easy part, okay? But now look, just like before, we're left with a quadratic. We've got our safety couch, okay? And I need to solve the remaining 2 zeros out of that quadratic. So this does not factor. You've got a 1 at the end. 1 times 1 only equals, or the only 2 things that can multiply to give you 1 are 1 and 1, which equals 2 and not 3, or -1 and -1, which added together gives you -2. So I'm going to have to use the quadratic equation on this. So I'm going to divvy this out, and I'm going to do this up here. I'm going to solve it out. So x equals -b plus or minus the square root b squared minus 4 times a times c all over 2 times a. And then up here I get 9 minus 4, so I get 5. So x equals -3 plus or minus the square root of 5 all over 2. -3 plus or minus the square root of 5 all over 2. Now this doesn't simplify. This is a quadratic that doesn't go any further. So therefore we're done. This is our last two zeros. These are our last two zeros. And notice they occur as a pair, the plus and minus. That means they're a pair of zeros. So our three zeros are, well, the first one was 2. Then we've got -3 plus the square root of 5 all over 2. And -3 minus the square root of 5 all over 2. Okay? -3 minus the square. So, and notice these are complex pairs. This is a conjugate. -3 plus the square root of 5, -3 minus the square root of 5. Okay? That's what I was talking about earlier when I said irrational. This is an irrational zero because it's got the square root here. Okay? It doesn't go away. That means it's an irrational zero. It's two rational zeros. Okay, questions before I go on to an even kind of heavier example. I'm going to look for one. If you guys have a question, let me know. I'm going to look for one of these before we go on. Okay, yeah. Yeah, okay, I'm going to steal one of these from your book now. This is number 24 in your book, in your homework. It's on page 387, number 24. Well, I only did graph table. Well, we solved it too. Part C was solving it. So number 24 looks like this. It says, instead of a function, it gives us as an equation, and we're going to treat it like a function. So it says x to the 4th minus 2x squared minus 16x minus 15 equals 0. Now it asks us to solve these. It says list all possible rational roots first, and then use synthetic division to test the possible rational roots and find an actual root. We're going to use the graph and the calculator. And then use the quotient from part B to find the remaining zeros and solve the equation. So they even give you the steps here. Now, their part B is what we're going to do with the graph, so we don't have to check every single possible rational zero, okay? So we don't have to check every single possible rational zero. We're going to do that with the graph. Now, look, I'm going to tell you from the get-go, I'm going to change this to a function. So it's already set to equal 0. I'm going to just call that my f of x. That way I'm doing the same exact steps as I've done so far, because that's exactly how you're going to work this one. So on 24, if you notice on 24, it writes it as an equation. The very first thing you need to do is just write it as a function. Okay. And then I'm going to find all the rational zeros. So my constant's 15. So 15, 5, 3, and 1. And my leading coefficient's 1, which is nice. So again, the rational zeros are going to be nice integers. Okay? The rational zeros are going to be nice integers. Plus or minus 15, plus or minus 5, plus or minus 3, and plus or minus 1. Now look, what's different about this example compared to the other 2 or 3 that we've done so far is that this is a 4th degree polynomial. So let's talk about that for a minute before we get to graphing. So because it's a 4th degree polynomial, remember the goal is to get it down into a quadratic. And we're at 4 degrees, which means we have 4 factors. So that means I need to factor the first 0 out, or 1 0 out. That gets me down to a 3rd degree polynomial. Then I need to factor another 0 out, and that gets me down to my quadratic. So I'm going to have to factor out 2 binomials. I've got to factor out 2 factors, divide out 2 factors, I should say. I've got to divide out 2 factors to get this down into my quadratic, which we can solve using the quadratic equation, the square root methods, whatever. Okay. So this one is a little different, but just like before, I'm going to graph this bad boy. Okay. I'm going to go into y equals, and I'm going to graph this. So I'm going to do that right now. Y equals, so x caret 4 minus 2x squared. Ooh, I got to remember that when I divide. Look, there's no 3rd degree here. So I remember I need that missing term. And then I've got what? X to the 4th, 2x squared minus 16x minus 15. And I'm going to graph it. Mine's having to think for a while. Oh, wait, look at that. Oh, hey, it looks like this graph here. Mine's the blue line, guys. It looks like this graph goes through -1. And is it +3? I think -1 and +3. I can hit the table. Yeah, definitely. Look, at -1, at x equals -1 here, we've got a 0 for y. So that tells me it's a 0. And then at +3, at x equals +3, I also have a 0. So I know those are 2 zeros. Awesome. So boom, I've got 2 out of 4 of these zeros already. Okay. So from the graph, x equals was a -1, and x equals 3 are zeros. Now what's different though is I've got to divide each one of these out. So I need you to be careful. You're going to divide out one at a time. So I'm going to just start with this -1. So I'm going to go back to this polynomial. Don't forget the x cubed. So -1, 0x cubed, right? I need that missing term. -2, -16, -15. And then bring down the 1, -1, -1, 2, no, +1, -1, +1, -15, +15. Yeah, there we go. And 0. Okay. So I've divided out -1. Now here's what I have. So this function now is, remember it's x plus 1 because I divided out -1. And it leaves me with this 3rd degree polynomial. X cubed minus x squared minus x minus 15. Okay. X cubed minus x squared minus x minus 15. And now I've got to divide now. So I've got one of these already done. If you want to put a big X here, we divided it out. Now I've got to divide out 3, but I don't go back to the original. That's just going to bring me down to a 3rd degree. I'm going to go to this 3rd degree polynomial here. And I'm going to divide this x equals 3 out. And it's going to pop out x minus 3, right? Because 3 is the 0. It's going to pop out x minus 3. And it's going to leave me with a quadratic. Okay? So I'm going to do that now. So I'm going to put 3 in. That's the 0. But I'm going to do it with this 3rd degree polynomial. Because I know 3 has to be one of those zeros left over. 1, -1, -1, and -15. Bring the 1 down. 3, 2, 6, 5, 15, and 0. Okay? So be careful. Do not divide this out of the original, right? Go back to the second one, to the one that we've been working on. So what does this tell us? Now our function is x plus 1, x minus 3, and then we have a quadratic left over. Yay, the crowd goes wild. Okay, x squared plus 2x plus 5. And I'm going to pause it right here. Okay. And look, I can find the last two. I know, hey, you know what? Those last two are on our graph. Now, they might be really big numbers, so they didn't get into the, the view of the graph. Or what's probably happening is those last two are imaginary, okay? The last two are probably imaginary because we didn't see them cross the line. Remember that one previously that was irrational? It still crosses the line. It's just irrational. It doesn't cross it at nice integer numbers. So for this one, we are going to have to solve it. I'm going to do the quadratic equation again. So we get x equals, do the quadratic on this guy. So -2 plus or minus the square root, 2 squared minus 4 times a times c, all over 2 times a. Under the radical, I wind up with, that's 4 minus 20. Oh yeah, that's an irrational. Or that's an imaginary, so -16. So we get x equals -2 plus or minus the square root of -16 all over 2. Well, the square root of -16 is just 4i. So we get -2 plus or minus 4i all over 2. And then I can divide all of those by 2. So we wind up with -1 plus or minus 2i. And that's my conjugate. Remember, again, and I know I kind of zoomed through that. I need to get one more example in. I've only got like 10 more minutes. But remember again that imaginaries and irrationals will occur as pairs. This is a pair, right? -1 plus 2i, -1 minus 2i. And that's all 4 of my zeros. It was what? The first one was -1, +3. We got those from the graph, right? And then -1 plus 2i, -1 minus 2i. But that's all 4 zeros. And those last two, you will never see on the graph because our graph is a real function, or is real. It's in the real, it's the real number system, not the imaginary number system. Okay. Great. Okay. Okay, let's look at 22. This will be my last example. Guys, and it's because I'm running out of time. I want you to look at, before you start the homework, there's okay, first off, your book talks about Descartes' rule of signs. Don't worry about it. We don't need it. Okay. I want you to look at example 5 on page 380, because it talks about when a function bounces off the graph and how to solve it out. So I want you to look at that, and I want you to, I guess, do that as part of the homework, but just at least look and see how the book does it. The book does a really good job of explaining how they solve these out. Okay. So look at that. I just don't have time to get to one like that and the one I'm about to go over. And I'm going to choose the other kind because it's a little more tricky than bouncing graphs. So what I'm looking at is actually number 22 in your book. Yeah. Oh. Where was I? Yeah, 22. So 22 says f of x equals 2x cubed minus 5x squared minus 6x plus 4. Now remember, I'm writing these as functions, and I'm not going to consider them equations. I'm going to consider them functions, and we're finding zeros because it's all the same thing. So 2x cubed minus 5x squared minus 6x plus 4. Right off the bat, just to get a little intel, look, it's a third degree, so I know I'm going to have 3 zeros, right? I'm going to have 3 zeros. And let's find the potential rational zeros first. Potential rationals. I've got 4, so that's 4, 2, and 1, right, as my constant. My leading coefficient is 2, so that's 2 and 1. Hey, we're going to get some repeating potentials, I'm not going to write them if they're repeating. And you'll see what I'm talking about here, okay? So the potentials are going to be, well, 4 divided by 2 is just 2. 4 divided by 1 is just 4. 2 divided by 2 is 1. 2 divided by 1 is 2. Well, it's already there, okay? So I'm not going to worry about that one. 1 divided by 2 is 1/2. 1 divided by 1 is 1. It's already included. So that is our potential. That's the list of potential rational zeros. Okay, great. So let's graph this one. And what you're going to see, this one's a little different than the previous ones we've done. So I'm going to say y equals 2x cubed minus 5x squared minus 6x plus 4. Oh, not plus 44, but plus 4. When you graph this one, you'll notice all 3 of these here. Hold on, let me see if I can see this one. This is why I chose this one. All 3 of these zeros do not occur at a nice integer 0, okay? That's kind of hard to see there. My hand's kind of shaking. But all 3 of these, if you look at them, now if you go to table, you'll see that too. I mean, we can go up and down on the 2, 4, and 1. You'll see that there's no 0 on the right-hand side here. Look, if we go up or down, we're not going to get a 0. Okay, so it means that none of the nice integer x's are going to give us 0. Oh. And that's not a huge deal, but I wanted to go over this because we've got these potential zeros, but we know if you look at that graph, if you got that graph in front of you, you will know that positive or negative 2 is not a 0. Positive or negative 4 is not a 0. Positive or negative 1 is not a 0. But it's a third degree. So that means we have to have at least one rational 0, right? Because all the other kinds occur as pairs. So we have to have one. So that means it leaves us, by deduction, right? It leaves us that we either have a positive 1/2 or a negative 1/2 as a 0, okay? So if I go back to my graph, if you look at that graph, you will be able to see that the line crosses the x-axis between 0 and 1, not between -1 and 0. So therefore, I think x equals 1/2 is a 0, okay? I think x equals 1/2 is a 0. I'm going to test it, but I wanted to do this one because it's a little different. It's just a little different because none of the zeros are nice integers. So I'm going to do 1/2. I'm going to divide it out to -5, -6, and 4. I'm not missing anything, right? 3, 2, 1, 0. No. Bring down the 2. 2 times 1/2 is just 1. Add that, you get -4. -4 times 1/2 is just -2. Add that, you get a -8. -8 times 1/2 is just -4. Hey, we were right. This winds up being a 0. Okay? This winds up being a 0. So therefore, we were right. 1/2 is a 0. Okay? It's not -1/2. And it wasn't the other ones too. We saw it from the graph. So by deduction, we found that 1/2 is a 0. Now we just have to find the last two. Now, guys, this one's a little easier, right? Because it's a third degree. I just need, now that I've divided this out, I know that f of x equals x minus 1/2 times 2x squared minus 4x plus, or minus 8, not plus 8, minus 8. It left us with a nice quadratic, okay? So it left us with a nice quadratic. Now I'm just going to solve out that quadratic, and we'll have the last two zeros. It's not like the one before where we had to divide it out twice. Okay, so 2x squared minus 4x minus 8 equals 0. I'm gonna actually, all these are even, guys. Do you see that all those are even? I can divide all those by 2. There's nothing wrong in that, as long as you do it to everything. X squared minus 4x minus Oh, not 4x, but 2. 2x minus 4 equals 0. I'm gonna have to use the quadratic. That doesn't factor. Actually, I know it doesn't factor because it doesn't give us a nice answer. I know my last two zeros are gonna be irrational. They have to be irrational, right? I mean, it can't be, the only other rational zero is the negative 1/2. It's not a zero. Our line doesn't go through there. It can't be imaginary because we see that it goes through the line. So it has to be irrational. The last two solutions have to be irrational. Okay, so I'm going to solve it out. X equals 2 plus or minus the square b squared minus 4 times a times c all over 2a. Underneath the radical, we get 4 plus 16. So we get 20. So we get x equals 2 plus or minus the square root of 20 all over 2. And we have to remember how to simplify radicals and simplify fractions. And if you're like, man, I don't remember how to do this, go back to 1.5, simplifying radicals. We went over that, or if you want to Google it, that's fine, simplifying radicals, and then simplifying quadratic equations. You'll see a lot of that in 1.5 and also just on YouTube. I mean, if you're on YouTube or whatever resource you use, this is a common math difficulty. So it's out there. So 20, I like to do the factor tree. I got a pair of 2s. So I wind up with 2 plus or minus 2 squared of 5. That's the 20 simplified. And then all 3 of these are divisible by 2. So I've got to do that. I'm going to divide all 3 by 2. And you wind up with 1 plus or minus the square root of 5. And notice, again, it occurred as a pair. And if you wanted to find those actual numbers, I'm out of time now, but if you want to find those actual numbers, it'll be where our line crosses at those other 2 spots on the graph. So our zeros for this example were 1/2, 1 plus the square root of 5, and 1 minus the square root of 5. Okay? Okay, for homework. Now, guys, I'm going to stay on here. If you want to ask questions, you're more than welcome to. But for homework, I want you to do them. Now, look, if it mentions to use Rene Descartes' rule of signs, don't do that. Don't worry about it. Just solve the zeros, okay? So I want you to do 1 through, excuse me, 1 through 23. These are all going to be odd. 1 through 23. And then the 33 through 51 is when it asks you to do the Rene's Descartes rule of signs. 33 through 51. And I just want you to do all the odd ones. Okay, it's on page 3. It starts on page 386. Okay, so I'm going to stop the live stream. And if you guys have any